All right, well, let's go on and move on to the cotangent function. All right, and what I decided to do here was actually just show you what the graph looks like and just kind of work from there. And so you might want to just pause it real quick and just copy down the entire left side, and then we're going to move on here, okay? So if we actually just work kind of backwards here, do you see here that one period, if you just start from right here, it's from 0 to pi, right? Or even if you look at this part of it, from pi to 2 pi. So one cycle or one period is pi right here. You see, it doesn't matter if you start from right here and then if you end here, it's always going to be an increment of pi. And so that's why we're going to say that our period is going to be pi right there. And then the asymptotes are always going to be at the in increments of pi as well. Well, let's go and figure out why though. I mean, why is this happening? We always want to understand the why behind mathematics, so that we're not memorizing rules. We want to understand the foundation and the reason behind all these nerdiness. So, like for example, okay, watch. If you go to 0, on the unit circle, and let's just remember that tangents of theta is sine theta over cosine theta. But now if we're going to now find the cotangent, as we're trying to find now, the cotangent is the reciprocal, right? So we're just going to flip that. Cosine of theta over sine of theta, which, in other words, it's our x over our y. So watch this. If I go to 0 on here, 1 divided by 0 is undefined. So at the point 0, I get undefined. See, because the x coordinate divided by the y coordinate is going to be undefined. Now, what if I go to pi over 4? Pi over 4. Well, if I go to pi over 4, x divided by y, well, that's just going to be 1 right there. And, so pi over 4 is about like right here, a quarter, and so there would be 1, you see? If I go to pi over 2, if I go to pi over 2 right here, and then do the cotangent, which is x over y, well, x divided by y, well, that's just going to be 0. And so that's why we have the point pi over 2, 0. So that's pi over 4 plus another pi over 4 plus another pi over 4, so 3 pi over 4. If you see there, I do x divided by y, which is going to be a -1. And if you go right here to 3 pi over 4, I get right here -1. You see? And last but not least, if I go to pi, x over y is undefined. So positive pi would be undefined. All right, so what we just did right now, we just derived the critical or the key points for cotangent, and the pattern just continues. At every pi, 0, pi, 2 pi, 3 pi, 4 pi, we're going to have what we call the vertical asymptotes. And I hope that this also makes sense that, look, see how the vertical asymptotes, as we learned back in chapter 2, is what makes the denominator 0. So what thetas are 0 right here? Well, those are all the y coordinates. Well, look, see how that's a y coordinate of 0? And then that's a y coordinate of 0. So at 0, at pi, at 2 pi, at 3 pi, at 4 pi. See how that's why we have these vertical asymptotes. And if you want to figure out where does this graph cross the x-axis, well, that's what are the zeros of the numerator. So what values of theta will make this guy 0? Well, look, that's going to be at pi over 2 and at 3 pi over 2. So watch right here, pi over 2, 3 pi over 2, and then it's going to keep going right here. Let's see, 1, 2, so 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2. So, I mean, you can continue the pattern right there. So that's kind of how you can figure those little things out.